guys. All right, here we go. We're on the back, and we're ready for some more definitions.
Now we have to graph.
All right, it says the degree of a polynomial function. Okay, the degree of a polynomial function affects the shape of the graph and determines the maximum number of turning points or places where the graph changes direction. Let me repeat that sentence before I continue. The degree of a polynomial function affects the shape of its graph and determines the maximum number of turning points or places where the graph changes direction. It also affects the end behavior. It also affects the end behavior or the direction of the graph to the far left and to the far right. So what I'd like you to do, if you have a graphing calculator, and I did post that on Schoology that I asked you to bring your graphing calculators today. I'm going to pull mine up. Okay, and what I'm asking you to do, hey guys, what I want you to do, if you have a graphing calculator, I want you to put in where you go, press your home screen, open a new document, and we're gonna look at even and odd graphs. So let me show you what mine looks like, and we'll kind of play with this just a little bit. Let me see. There we go. Okay, good. All right, so you press document and do a new document, and you want to do add a graph. And we know what x squared looks like, right? But let's go ahead and put in there x squared. Now here's what I mean by end behavior. I want you to look at my hands, okay? And we kind of talked about this in a different kind of way when we graphed parabolas, but it goes up, up. Okay, on the left side it's up, and on the right side it's up. What happens when we put a negative out front? It goes down, down. So the direction of the graph at the ends, okay, that's why it's called end behavior. As it goes forever and ever, where is it going? So now watch. I want to go back, and I want to change this to, let's do x to the 4th. Do you know where your little caret button is? And let's call it x to the 4th. And this looks really similar to my x squared, except it's not a parabola, but it flattens out here. Do you see that? It kind of flattens out. So if you do x to the 6th and x to the 8th, it is still up, up. Okay, on the left side it's up, and we always say the left side and then the right side. Yeah.
How come it does that?
Well, think about it. If I had 1/2, okay, if I plug in x is 1/2, and I take it times itself 4 times, that's 1/16. That's super small. So as you do the fractions between 0 and 1, and you're taking a fraction times itself 4 times, it's getting smaller and smaller. Because in the top is 1 times 1 times 1, but the bottom, it's 1/16 is much smaller than 1/2. All right, so now, all of the even graphs have the same end behavior, up, up, and if there's a negative out front, it's down, down. So now watch this. Let's go to a new graph, and let's call it x to the 3rd power. And this is really going to be the only ones that we're going to have trouble with. So what I want you to notice is that when I do an x to an odd, and think about a line, okay? Okay, think about a line. When I did a line, it went down on the left, up on the right. Well, the only thing that's changing is that as I do x cubed, it's just shooting down faster. So it's down, up. And watch what happens if I go and if I stick a negative out front, watch this. Uh-oh, what happened? So here was x cubed. It reflected, okay, it reflected over the x-axis. Do you know how x evens do this and negative x evens do that?
Mm-hmm.
Well, here's x odd, and this is negative x odd. All right, so what I want you to do is I want you guys to stand up. Okay, stand up, put your pencils down. Okay, and here we go. We're just going to move our arms a little bit, okay? So if I say to you, I have x to an even power, put your hands up. It's up, up. If we put a negative x even, it's down, down. Now, do your arms like this. This is x odd. So your right hand is up. So it goes down, up. It's down, up. When you put a negative in front of the x odd, it's up, down. Okay, so let's do them one more time. So x even, up, up. Negative x even, down, down. X odd is down, up. Negative x odd, up, down. Does that make sense?
Yes.
All right, go ahead and have a seat. So watch what we're going to write down here. It says, in general, the graph of a polynomial function of degree n has at most n minus 1 turning points. So if you look at my example, f of x equals 3x to the 6th plus 2x plus 8. What is the degree on this one? Okay, so my degree is 6. So if the degree is n, the maximum number of turning points is n minus 1. So f of x has what maximum number of turning points? 5, because it's 1 less. All right, so now what we're going to do is we're going to write down, if I have ax to the n power, if I have a is positive, okay, if a is positive, we just did this with our arms. All of the positive x to an even, okay, this is x to an even, the n behavior is up, up. If I have a negative, okay, so this means a is less than 0, my n behavior is down, down. And this is negative x to the even. On an odd degree, it looks like this. This is x to an odd power. So x cubed, x to the 5th, x to the 7, x to the 9. It's going to have n behavior down, up. And then what happens if I put a negative out front, it reverses it. So if I have negative x odd, the general graph, now I can have wiggles in the middle, and I can have hills and valleys in there, but in general, this is x odd, and a negative out front flips it. So my n behavior, we always, like you read a book, you read from left to right. We read a graph from left to right. So this is up, down. So it's where is the graph going when I go very, very far to the left and very, very far to the right? Where do those arrows aim? All right, so we have something called the leading coefficient test. And the leading coefficient test says if you look at the highest degree, okay, if you look at the highest degree, the other parts will kind of go away. And so watch this. I'm only going to look at the coefficient to see whether it's positive or negative, and then the degree. So when I look at 4x cubed, that's positive, and it's odd. So you want to make a little sketch like this, like the one in the box. So this is down, up. Now let's look at letter B. I only need to check the highest power, or the degree of the polynomial term. So if this is negative 2x to the fourth, what does the shape of the graph look like? Down, down, right? Because x to an even is like our parabola, so the end behavior is down, down. All right, I'm going to pause, and I want you to try C and D. And then look at the box, your 4 options. Okay, look at the 4 options. So letter C is 7x to the fourth. So that's up, up. Letter D is negative 4x to the seventh. So it's flipping it, and this would be up, down. So really, you've got 4 options. Up, up, down, 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 up, down. It just goes in those 4 ways. All right, when you're ready, flip the page. And now what we're going to do is we're going to connect this to actually what the graph looks like. So in example 3, it says use a table to graph y equals x to the third minus 1. So let's start with 2. If I take 2 cubed minus 1, 2 cubed is not 6. When you cube something, it means you take it times itself. So 2 times 2 is 4. 4 times 2 is 8. 8 minus 1 is 7. What's 1 cubed? 1 cubed is not 3. What's 1 times 1 times 1? 1. 1 minus 1 is 0. What's 0 cubed minus 1? Negative 1. Negative 1, when I cube it, a negative 1 times a negative 1 is positive 1. Positive 1 times negative 1, this is negative 1 minus 1. That's negative 2. All right, now try the third one on your own. What happens when you plug in negative 2 cubed and then you subtract 1? What'd you guys get? Okay, got it? Yeah, man.
Negative 7?
No?
7?
Isn't that negative 8 minus 1?
Oh, shoot, negative 9.
That's negative 9. All right, so let's plot this. I have 2, 7. I have 1, 0, 0, negative 1, negative 1, negative 2, negative 2, 9. Okay, hey, this is really cool. It looks like what we were getting on the graphing calculator, okay? So, what would be the end behavior? How do you describe it? It's the up, up, down, down, up, down, down, up. So, isn't the end behavior? On the left, it's down, and on the right, it goes up. There are no turning points. A turning point is a hill or a valley, okay? And then what I want you to notice, there's something called increasing and decreasing. And if you were to eventually get into calculus, you do increasing and decreasing. Do you notice that the whole way this graph increases? It's just always going up. So this increases from negative infinity to infinity. And it does not decrease at all. All right, if you have a graphing calculator, you can easily do these graphs. So you can pop it in there, and actually you can get the table from the graphing calculator. But for those of you that don't have one, we're going to do it by hand, and we'll get there. But I should anticipate, this is a negative x cubed. So it should go like this. Like I should already anticipate my end behavior just based on our exploration. So this is negative 6 minus a negative 8 Negative 6 minus negative 8 would be positive 2. 3 times negative 1 minus negative 1 cubed, that's negative 3 minus negative 1, so that's negative 2. If you plug in 0, that's just 0. If I plug in 1, 3 minus 1 is 2. 3 times 2 minus 2 cubed, 6 minus 8 is negative 2. So let's plot these and see what's happening with our graph. And the good news is, I know I'm going a little bit fast today, but it's because I needed to get this in. Tomorrow we're going to go over the graphing and the last part that we do again, so don't panic. So here's negative 2, 2, negative 1, negative 2. Here's 0, 0, 1, 2, and 2, negative 2. Now when you plot these, you might be thinking, whoa, what's going on? This doesn't even look like anything I know. And in fact, you do know. Here's my end behavior, right? I know because it's a negative x to an odd, it looks like this. So that means it's coming up from here. It came down. It hit here, and it's got to go back down as part of my end behavior. This is so cool how this all connects together. So you have to have an understanding of end behavior in order to take those points and make sense of them. So my end behavior is up, down. All right, turning points is how many hills or valleys do I have? Do you see I have a valley and a hill? That's 2 turning points. All right, now this part, students always struggle with this, about the increasing and decreasing. We use x values, okay? We use x values to describe the increasing and decreasing. So my x value is negative 1, and this x value is positive 1. So it's increasing from negative 1 to 1. I don't mean the y values, I mean the x values. Okay, we describe increasing and decreasing with x values. Now, it decreases everywhere to the left until I hit negative 1. So watch this. That's negative infinity to negative 1. Okay, so it's going left forever. It really does, but it shoots up as it continues to move left. Then it's going to decrease from my hill everywhere to the right. So that's 1 comma infinity. So let me kind of go over this one more time, okay? So you're going to make a sketch using a table. Then you've got 4 options. You've got your up, up, down, 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 up, down. Those are your x even, x odds. So when you're plotting these, you've got to be thinking about your end behavior. Okay, you've got to think about it in order to be able to make your sketch. And so, like, sometimes there's wiggles, and sometimes there weren't wiggles. So let me go back to the one just above it. Do you see there were no turning points here? This was going up for the whole way. It didn't have a hill, and it didn't have a valley. So sometimes they have it, and sometimes they don't have it. And you don't know until you plot some points to see what's happening there. Okay. All right, then let's look at example 5. It says you can determine the type of function you have using a table. And what you do is you do consecutive differences, okay? And what I mean by that is, so we're going to call this the first set of differences. From negative 1 to negative 7, didn't that go down 6 values from negative 1 to negative 7? It went down. From negative 7 to negative 3, that went up 4. From negative 3 to 5, that went up 8. From 5 to 11, that's up 6. From 11 to 9, that went down 2. And from 9 to negative 7, that went down 16. So let me restate it in case I lost you here. what I'm doing is I'm taking the differences of the y values. And for those of you that need a calculator, you would do -7 minus -1. You take the second one minus the first one, okay? So, okay, that's my first differences. And what I'm trying to do is now I'm going to take the differences of the differences. So from -6 to -4, that's up 10. From 4 to 8 is up 4. From 8 to 6, how does that move? Down 2. How about 6 to -2? Down 8. And then how about from -2 to -16? Down 14. All right, and what I'm looking for is I'm trying to find a constant, okay? And that's going to tell me my degree. So this is cool. Here we go. So if I go from 10 to 4, that's down 6. From 4 to -2 is down 6. From -2 to -8 is down 6. And from 8 to -14 is down 6. This is called a third degree polynomial. So this technique works if you have consecutive x values and you take common differences, okay, you take differences between your y values. Let's do one more just to make sure you're getting the hang of this. So flip it over to the last page. So however many differences you have to go will determine the degree of your polynomial. All right, so flip it over when you're ready. So here we go. And I like to write it out, like this is my first set. And if you need a calculator, use a calculator. But if you're going to do a calculator, you do -16 minus 23. So that went down 39. You would do -15 minus -16. That's up 1. This is up 5. This is down 3. Up 1 and up 41. I'm going to pause and give you a little bit of a head start on me and see how many differences it takes to get a constant. And that will be the degree of the polynomial. Pretty cool. So I got it on my fourth difference. So this is a fourth degree polynomial.